Hello, I'm Roberto Lollini. I'm the head of Energy Efficient Buildings Research Group. We are here at outdoor laboratories of URAC Research, and we are in front of the prototype we developed within CIRAF project. CIRAF is a project in the framework of EIC grant. We are here with Miren, the scientific coordinator of the project. So Miren, which is the innovation about?
So this is an adaptive opaque facade that can change its behavior based on the weather conditions and the environmental conditions that we want to reach inside the buildings.
And which behavior you can change?
So we can pass from being really insulated, so as many of the technologies that we have right now in the market, we can minimize the heat exchange to avoid heat losses in winter or unwanted heat gains in summer. But what makes this technology special is that we can shift that behavior to be actually a heat exchanger, so enhancing that there is a heat flux through the building envelope.
That's interesting. How do you do that?
So when we open the kinetic cladding, we enable the solar radiation reaching the layer that has a high solar absorbance. So for instance, in this prototype, this surface is black so that it gets warm when it's in contact with the solar irradiation. Then this high temperature that we reach hits the air that is inside the active insulation system, and we can transport it to the inner surface of the active insulation system, finally warming up the indoor environment.
So you move the heat by moving the air.
Exactly, and once that we stop the air movement, it is again a regular insulation that blocks the heat exchange.
So in this way you can save energy for heating.
Exactly, but also for cooling demand. So for instance, in a summer day, we would close the kinetic cladding so that we can reflect the heat that arises by solar radiation, and we would have the air inside the active insulation system still. So we would be minimizing the heat gains reaching the indoor environment. However, for instance, in the same day, if during the night the outside temperature is lower than the inside one, we would start moving the air within the active insulation system, and we would also open the kinetic cladding again so that we can have convective movements really close to the facade to maximize the heat losses. And like this, we would dissipate the heat from the inside of the building to the outside.
I see. So it is a quite complex project in which there are many disciplines involved. I can see thermodynamics, building physics, material science. Also, I mean, you have to take into account some architectural aspect. That's interesting. It's a multidisciplinary project.
Yes, let me show you how the team is working. So first, we conceptualize the technology, that it's the materials we need as well as the geometry.
And which are the drivers you consider in the development of the system?
So of course the capacity to block and allow the heat transfer, but also the design for assembly and disassembly, and the carbon footprint of the system.
As well as the prefabrication and future industrialization of the technology.
See. Thank you.
And then we model the technology both at component and building level to see what happens in different conditions as well as different applications.
And we wanted to know to which extent the heat was transferred or blocked in the different configuration of the technology.
As well as the impacts that this behavior would have had on building topologies in different climates and contexts in terms of indoor thermal comfort and also building energy consumption.
And the CO2 emissions related to the material choice of the facade and related to the heating and cooling consumption of the building.
So then we prototype the technology to do the lab test.
Okay, and how was the manufacturing of the prototype?
Let's talk about that with the colleagues that were in charge of it.
Hi, Pablo.
Hi, Roberto.
Miren told to me that you developing in your company, Indresmat, a kind of new material, a bio-based material made of polyurethane but with bio ingredient. And with this you built the active insulation system that Eugene and René conceived at the beginning. So how does it work? How did you do with your material?
Well, that's true. We developed the bio-based material for insulation. As a company, we develop a bio-based polyurethane that we can adapt to any single application. And this material is highly versatile and indeed bio-based.
Okay, and what does it mean bio-based? So which kind of components or ingredients you use it for your material?
Mainly these are natural oils. These kind of natural oils are widely used in cosmetics, so they do not compete with the food industry. And these materials are also implemented at large scale, which is also scalable. The good thing is that this material can be used to incorporate some channels that are required in the insulation system that is for this project for Seraph.
Okay, that sounds great. Pablo, I understood your material. How does it work? And congrats, it sounds great. So to see if the material is able to enhance or block heat exchange, we have to talk with the expert. So, I would like to invite Francesco, the expert and who followed the test in the lab.
Okay.
So thank you very much. Thank you. Hi, Francesco. Hi. So,
Yes, you absolutely said correctly before with Pablo. We are doing tests. It's very important this phase to assess actually how the component works and behaves. So here in our indoor labs, we have two climatic chambers that we can fully control to simulate the indoor and outdoor environment. And in between, there is the active insulation system that we again can control to have it in the blocking way or fully let's say enhancing the heat flux way. And so we can check how is the behavior in these two behavior of the component, and we can measure everything in this facility. So what we're doing right now is to get all the data that we need that is going to give us very reliable data results and also enable us to be sure about our models. Once we do that, we are also in parallel doing something similar for the kinetic cladding at the outdoor facility, in which we test the kinetic cladding in different positions, so fully closed, fully open, or in between states. And once the two components are completely characterized individually, we will put everything together, build the first ZIRAF system, and characterize it outdoor.
the next step would be to install in a real building to demonstrate in operational condition the system.
Absolutely, that is the dream, let's say. We will, that's the next step.
Super. So let's see how the actuator of the kinetic cladding works.
That's really interesting. I suggest you talking to Miguel about that. Thank you, Roberto.
Thank you. So Miguel, was you and your company, Impulse Smart Shading, that designed and built the actuator for the kinetic cladding, so that enabled the kinetic cladding to move autonomously?
Yes, in our company we explore the use of shape memory alloys to actuate architectural devices like this.
What is a shape memory alloy?
Shape memory alloy is a smart material that can be deformed in cold state, and then when you heat it up, it recovers the original shape. In our case, we are using it to actuate the kinetic cladding in our project Seraph.
So instead of a motor?
The material itself is a sensor and a motor at the same time.
So the technology is still in the development phase. How can we envision the possible future applications?
So the technology is versatile enough to be implemented both in new and existing buildings, but if we do so in existing buildings, we need to consider that the aesthetics of the facade will change.
Okay. And so how you can imagine to integrate this ZIRAF technology in real buildings?
Yes, so being ZIRAF an adaptive technology, the integration in building is really dependent on the control strategies that we are going to use and develop. So the key part will be considering taking into account the dynamics of buildings and also of its components as operable windows or adaptive shading systems. And we will of course do that and also exploit the best way possible data.
Indeed, that data is really very important because it allows us to effectively control the heat exchange through adaptive facades. A couple of years ago, this may have been very complicated, but with recent developments in building simulation, but also Internet of Things, artificial intelligence, digital twins also, this is more within reach than ever before.
Yeah, so hopefully if we put all these advances together, we can have more sustainable and energy efficient buildings thanks to our technology.
So looking forward to the results of this project and a successful proof of concept we discussed today together.